All right, so now what we're going to do is we're going to approach another kind. It's sort of a between question. Remember how I said when you see this right here, when you see an X in the middle of two less than symbols, they can be less than or equal to, or they can just be less than. Whenever X is between two less than symbols, okay, we call this X is between. Okay, that's what we call it. And so that's what we're going to do in this particular video is we're going to look at situations where we're looking for probabilities where X is between a number that is not the lower number, not the upper number, it's some other number, and X is between that number and A. And we're trying to solve for A in order to get a specific proportion. Well, solving this is no different than the ones where you solve for X is less than or X is greater than A. It's the same procedure. You're just going to put this number in, 4.18, instead of putting in 2 or 15. And then other than that, it's the exact same thing. So suppose a random variable X is best described by a uniform probability distribution with range from 2 up to 15. All right, so we're going to need a PDF. Our PDF is going to be 1 over 15 minus 2, which is 13. Okay, so 1 over 13 is our PDF. Find the value of A, find the value of A that makes this statement true. Okay, and so the formula is going to be the exact same thing. We always do the same thing. We do the probability density function, 1/13th, times some interval, a number minus another number. That's what we always do, okay? So what numbers are we going to do? Well, A is the larger number here, and 4.18 is the smaller number, because X is larger than 4.18, but it's smaller than A. So A is the larger number, so we're going to say A minus this other number, 4.18. So A minus 4.18. And that's going to be equal to whatever this probability is, 0.35. We're going to solve it the same way. We're going to cancel the 1/13th. So we're going to multiply by 13 on both sides because we're still doing it. It's still algebra. Okay. Over on the left side, it's going to cancel. And over on the right side, we want to do 0.35 times 13. So 0.35 times 13. And that gives us 4.55. So over here, we're going to have 4.55, okay? And then over here, we're going to have A minus 4.18. Now we just add 4.18 to both sides, and we've got our solution. This cancels, and we have A is equal to, so we're going to have 4.55 plus 4.18. So 4.55 plus 4.18, and that gives us 8.73. So the other number is 8.73, okay? So the probability of X being between 4.18 and 8.73, okay? So the probability that X is going to be between those two numbers is 0.35. Okay, let's try another one just like this. All right, suppose a random variable X is best described by a uniform probability distribution ranging from 23 up to 54. So our PDF is going to be f of X is equal to 1 over 54 minus 23. That's looks like 31. So 1 over 31, okay? And it says find the value of A that makes this statement true. So X is larger than 30.21, but less than A. So we know that A is a number larger than 30.21, and that the probability that X is going to be between these two numbers is 0.59. And so we're going to set up our formula here. So we're going to do our PDF, 1 over 31, times the larger number A minus the smaller number 30.21 is going to be equal to the probability 0.59. We're going to cancel the 1 over 31 by multiplying by 31 on both sides. Okay, it's going to cancel on the left side, and we're going to have A minus 30.21 is equal to whatever 0.59 times 31 is. So 0.59 times 31. That's going to give us 18.29. So 18.29. Now we're going to add 30.21 to both sides. 30.21 is just algebra. Cancel. And A is equal to 18.29 plus 30.21. 18.29 plus 30.21. Did I get that right? 30. Yep. And then enter. We get 48.5. So A is 48.5. That's our answer. That's the number that goes right here. And it is larger than 30.21. And the proportion in between those two numbers is 0.59. Okay. Let's try one more question. This one is a little bit different. It's not just like this one, but it's a similar solution. All right, if you look at this for a second, I think you'll be able to see how this is different than the last one. If you look down here, okay, and look right here, the A is now smaller than the other number. Previously, we had the number over here and A over here, but now 61.15 is the larger number, A is the smaller number. So instead of doing A minus 61.15, we'll have to do 61.15 minus A. And that'll add basically one more step to our algebra, okay? All right, so we suppose random variable X is described by a uniform probability distribution ranging from 19 up to 72. Since it's uniform, our PDF, very simply, is going to be 1 over whatever 72 minus 19 is, and that's 53. Okay, so our PDF is 1 over 53, and we want to find the value of A that makes this statement true. Okay, so we're going to set it up. We're going to do our PDF, 1 over 53, times the larger number, 61.15, minus the smaller, which is going to be A, and that's what we're solving for, and that's going to be equal to 0.43. 0.43. To cancel the 1 over 53, we're going to simply multiply by 53 on both sides. 53 on both sides. Over on the left, it's going to cancel. And then we're going to bring down the 61.15 minus A, is equal to, now let's do 0.43 times 53 in the calculator. 0.43 times 53, and that gives us 22.79. So 22.79. We want this A to be positive, so we're going to add A to both sides. That's just my way of doing it. You don't have to do it that way, but I figure it's one of the easiest ways to do it. So 61.15 is equal to 22.79 plus A. Now we're going to subtract 22.79 from both sides, minus 22.79. Over on the right side, this is going to cancel, okay? And we get equals A on the right side, and then on the left, we're going to do 61.15 minus 22.79. So 61.15 minus 22.79, and that gives us 38.36. So 38.36, and that's our answer. And so if we were to put 38.36 here in for A, we could say that the probability that X is between 38.36 and 61.15 is 0.43, okay? All right, well, that is it for the uniform probability distribution as a continuous random variable and calculating probabilities.